Sorry guys, when I went out of my camera app, it stopped my video recording. So this is continuing where I left off. I did check it on Wolfram Alpha, which is an excellent calculator for when you're doing homework and such. And it turns out that the limit does not exist because we do get this 1 over 0, and that's one of our danger signs that it's undefined. As x approaches 3, there is no limit. There's nothing to approach there. Therefore, the two-sided limit does not exist. We have a broken function here, or a function that isn't continuous. And so you're going to have... Now, you can find a one-sided limit. There are one-sided limits, but a two-sided limit does not exist. And that's what, when you type this into Wolfram Alpha, that's what it says. It says a two-sided limit does not exist. And then it gives you the one-sided limits, what they are. And so if we know that a two-sided limit does not exist, but we're asked to find the one-sided limits, oh shoot. You know what I just realized? I never went over the notation for a one-sided limit. So basically, when we're talking about a limit, if it doesn't exist, we're saying it doesn't exist from both sides. And so what I mean is, if you have a limit here, or a function here that goes like this, and these are the axes, by the way. And you're saying at this point it does not exist. At this point, the limit does not exist for both sides. So you can't approach the same value from both sides at this point of x. But you can see on one side, if you were to cover up one half of that function and see what value of y does it approach, well, it looks to me it goes closer and closer to infinity. It goes all the way up there. And that's just saying that it goes all the way to infinity, and so the one-sided limit is positive infinity. And this one, from this sided limit, if you cover this side of the graph up, it looks like it goes to negative infinity from that point. And so that's what we call this an asymptote. It's a very fancy word, and you probably heard it if you've taken algebra. If you haven't, well, it's a fun word, asymptote. It sounds like a sim toe or something like that, like a simulated toe. I don't know. Sounds kind of dorky, but that's the name of that. I'm sure it has a root in Greek language or something like that, but I don't know what that is. So anyway, that it just says that it's not continuous. So a limit at this point does not exist for this function. And therefore, you could find the two, a limit from either side, and that does exist. But the limit from both sides does not. I hope that makes sense. And now I'm going to go over the limit notation for those one-sided limits that I forgot to do earlier. One-sided limit notation. So you've got the limit abbreviation here of x approaches, let's make up a number, 3. So let's pretend on this graph up here that this value is 3. And so the limit as x approaches 3, well, if we're looking at it from both sides, positive infinity here, negative infinity here, the closer and closer you get to 3, going like, infinitesimally closer, like 2.999999999, it would be, if you say 2.9, for instance, would be, let's just pretend it's like 1.0 or 0.001, and then 2.99, if you put that in, it becomes 0.0001. So it changes. It doesn't get closer to the same number. The number changes. I'm sorry if that's confusing. not always the best at explaining things, but hopefully one thing that I say will make sense. I'm almost done here, guys. I know I'm drawing it out a bit, but I hope this helps. I really do. So we use a plus or a minus to indicate the direction we're coming from. And basically this is saying, where are you from? Like, where are you going from? Are you going from the positive side over here, coming this way? Or are you going from the negative side? You're always going towards that point. But are you going at it from this side, from the positive side? Or are you going at it from the negative side, from this side? And so that's all that plus and minus are saying. So that's the limit from... So the limit of this function, which we'll abbreviate by f of x, because I don't know what the function would be for that. There's a expression that graph correlates to, but I don't know what it is. I'm just saying f of x is that function. And so how I evaluate this is I say, well, I look at the graph from where it comes closer and closer to that point, but doesn't actually touch. And where are we headed on the y-axis? We're headed towards negative infinity. So from the right side, looking towards that point, the limit goes to negative infinity. It approaches negative infinity y 3x, but it doesn't actually get to 3x, or x equals 3. So it approaches, so the limit of, as x approaches 3 from the positive side of f of x of this function here, is negative infinity, because it's going towards negative infinity there. And so limit of, as x approaches 3 from the negative side, from the negative side, that's a minus. And that is talking about this part up here. As x approaches 3, as we get closer and closer to x equals 3, from this side, from the negative side, then of f of x, it's the function here, that equals positive infinity. And you don't have to write the plus. I just write it because it helps my brain differentiate. So that's how we notate it. And if you see, like, find the limit of that, then you know, okay, so this is what it is. And then I believe there's a problem in the homework where you're asked to find the one-sided limit of a piecewise function, and then another sided limit of a piecewise function, and then the limit of both sides. And if you're looking at the point where the function breaks in a piecewise function, there's no limit there. The limit does not exist at that point. And so, but you can find the one-sided limits. And so, on one of the answers to that problem is that the limit from the positive side is some number, and the limit from the negative side is some number, but the limit from both sides does not exist. So, and then I'm not going to go over an example of a piecewise function. I'll just kind of explain it. There's a problem in our homework that sort of looks like that, and I'm gonna go here. Let's go x. That's not 0. X equals 5. Sorry. redo. Let's go x equals 5 over here, and we're saying at -3. I know it's not to scale, but this is not a 0, this is a point. And she wrote a graph, the teacher did, last class. She didn't explain what she meant by this hole. This hole means that at this point there's actually no value. So it starts from here, but it doesn't actually include positive 5x, -3y. So, but you have a function that goes out like that, but it starts here, but it doesn't actually include that value. So it's greater than x equals 5. So that's what that hole is saying. I know a lot of people are like, what's the open circle versus the closed circle? Whereas this one, let's say this is x equals -6. Again, not to scale. But the point is, I think I'm reaching my limit here. I'm sorry. Dad jokes, I just can't help it. But anyway, this is saying that the point of y equals 5 and x equals -6 is included. So the domain here is less than or equal to -6. And so the domain here is x is greater than but not equal to +5. So basically, when you have a function like this, if you're asked to evaluate it within these bounds, the limit does not exist. But if you're let's pretend that my explanation breaks down because I didn't write them at the same point. So let's say it goes like that, and then this goes down to here, and it doesn't include that point, but it goes down to it. And this is the same point here, the same x value. So you could say, well, what's the limit here? Well, the limit does not exist because at this point, if you approach, you're not approaching the same value from both sides. Up here, it seems to be close to 0 or something near 0. Whereas if you approach from this side, it's negative like 4 or -5 or something like that. So this would be a two-sided value does not exist. So the limit as x approaches this value, whatever it is, we'll call it c, as x approaches c from both sides does not exist. And so, but if you were to say the limit as x approaches c from the positive or from the negative side, to make it simple here, it seems like as x approaches c from the negative side, which would be that minus, then of f of x, sorry, I didn't write the full notation, that equals 0, because it approaches y equals 0 as x approaches -c, or c from the negative side, sorry. So hopefully that helped. I'm sorry if I was a little convoluted or if I took a long time explaining. I just know some of you guys are desperate to understand this, and hopefully this helps. Some great resources that I recommend are using Khan Academy. A lot of people find that useful. That's how I was introduced to limits myself. And then I also found a very nice explanation of limits on a website called betterexplained.com. Just look up on Google Better Explained Limits. And it'll lead you to an intuitive explanation about limits, which really helped me understand sort of why limits are important and what they mean, and not so much of, okay, let's look at this problem here. And so that helped wrap my mind around it. But anyway, hopefully this helps. Ask me if you have any questions. Tell me if you like this video and want me to make more like it, and I'll see what I can do. But anyway, good luck with your homework, good luck with your classwork, and I'll see you later.